Okay, I'm David Taylor. I work for my own company called Sat Signal Software. Been doing that for about 5-6 years now and make my living selling weather satellite software. So that's the caveat, vested interest, me selling weather satellite software. And no, I can't take orders outside, sorry. So what I want to do, we've demonstrated weather satellite reception here for the last several years through the group for Earth observation, for GEO. And although I've certainly talked once before on the sort of the advances in satellites and what's new, I know that quite a lot of you have actually asked, well, how do I actually receive these pictures in the first place? So this is almost in the nature more of a sort of beginner's introductory class, and maybe it should have been the first session on day 1 rather than the last session on day 3, but never mind. So what I want to talk to you about, the type of weather satellites that we have, how to receive them either directly or how to get the higher quality reception through the systems like UMETcast that we've seen outside. Two types of primary weather satellite, polar orbiters, which are in a low Earth orbit at about 800 kilometers height above the ground, sun-synchronous orbit, and so typically at any particular location you'll get 1 or 2 passes per day in daylight and 1 or 2 passes at night. They're capable of resolutions typically of 1 kilometer in the standard satellites like NOAA 17, NOAA 18 and the newly launched European METOP satellite. And there are other satellites around that you can also get images from which are capable of resolutions down to about 250 meters on the ground, which are really quite good. And you can get those images off the internet even if you can't get them directly, if your X-band receiver is a bit playing up. We also have geostationary satellites that are at about 36,000 kilometers, as I'm sure you'll all know. And being a little further from the Earth, the resolution is slightly less on those. But because you've got continuous coverage of the same spot on the Earth, it makes it easy to produce animations. Now, I do have some animations, but maybe we shan't have time to play those. And I know they don't play through PowerPoint, so I'll see if I can do those separately at the end if the session chairman, oh, it's disappeared, good, allows me time. So, polar orbiting satellites, we've got 137 megahertz, and you maybe have seen outside the turnstile antenna that Francis Bell has been demonstrating polar orbiters from. Great advantage of that is that in fact you don't actually need a steerable antenna. You can actually manage without. The reception software you can have, it's a standard audio bandwidth signal, so a sound card in your PC or your portable. It's simple software that you can get on the internet that's either free of charge or you can upgrade, register, and people's software other than just mine as well. That allow you to do processing and automate the reception, maybe automate pictures going up to your website and so on. For the higher resolution, the 1 kilometer resolution data, you have to move to L-band reception, which means 1.7 gigahertz type of transmission. It probably means having to have a steerable antenna. I have once seen one of the NOAA satellites tracked by somebody sort of shouting, left a bit up, and sort of roughly tracking the arc of the satellite. But I think when you've done that once will probably be enough. So some sort of antenna rotor and steerable antenna driven from tracking software. The disadvantage of all this direct reception is that really you're limited to your local area because it's essentially line of sight reception. So that's fine if you want to know the weather in Europe, that's great, but if you want to sort of see some hurricane or something that's going towards the US and make a picture from that, then really you're a bit stuck. Now, I did actually have, just before we started broadcasting today, I did have an email query, so able to respond to that. Thanks to BATC for providing that facility for us. So Stephen, your request is now being played. I think you've already seen that on the Geo subscribers group, you'll have had an answer from Rob Denton in Bulgaria, who's also interested in building HRPT equipment. Now, I've talked with our local experts here, and at the moment we don't know of any commercial equipment that you can buy to do this. That's on an amateur basis. Firms like TimeStep, Dartcom in the UK. Dartcom are certainly doing commercial standard equipment, but that may be a little bit more expensive than you'd like to buy. A guy in the Netherlands who does a lot of hardware and software, you may want to look on the internet for Rob Alblas. I think it's alblas.nl is his website. He has a decoder for HRPT. So that may be some sites. And also you may want to ask on, say, Geo subscribers list or something like that, if somebody has some second-hand equipment. That's perhaps the best way to do this HRPT. There tends to have been, certainly in Europe, a little bit of lack of interest because of the next way that we can receive the data. For 137 megahertz, you can use, brief pause, 137 megahertz now, the APT reception. You've seen the turnstile antenna outside that Francis Bell has showed. This is a very popular antenna, QFH antenna. It actually matches the ones that they actually have on the satellite for broadcasting. It has a nice radiation pattern, so it's overhead. It's relatively low gain. Towards the horizon, there's an increasing gain, and that tends to nicely compensate for the path length losses. The sort of image you get is essentially a two-channel image. It's WeFax. Let me find a quick pointer here. Red or green? I wonder which comes out best. Where the left-hand side is showing you the visible channel. Right-hand side is showing one of the infrared channels. And you can see here, for example, Italy shows out, and Corsica and Sardinia show out very well on the visible channel, but not so well on the infrared channel because the sea and the land are about the same temperature at the particular time this image was taken. With the thermal channel, we tend in the sort of weather satellite area to operate with black hot. So that shows clouds that have got cold tops as having white, and warmer areas like the sea here around Norway showing as a darker colour. So you've got that two-channel image, basically WeFax, but with the addition of some timing bands in between and also some calibration marks so you can make sure the transfer characteristics linear. And there's other information in here as well that allows you to calibrate the data you've got. It's not just a pretty picture, it's actually something you can calibrate and make temperature measurements of. So, visible channel, you can tart that up a little bit of histogram correction, bit of stretching, whatever to make that look pretty. The thermal channel, you can perhaps use that to provide colouring information in an image. And then combining those two together in sort of standard TV techniques of colour and brightness, you can produce this image, false colour image that has a sort of reasonably attractive appearance. This image obviously done sometime perhaps nearer the winter than the summer, but it looks dark in Norway. And you can see you get a differentiation in cloud colours, the very coldest clouds being purplish and so on. But you can play with that, you can have great fun, you can put in your own palettes and see what you think, see what you find the best. There are some problems in receiving APT, particularly in the UK, because very near to what is a satellite band that should be a protected band almost, our UK authorities, despite the best protestations of whether satellite enthusiasts go and put pager band next to it. So for me, I've got a 200 watt pager transmitter is about 200 meters away from my house, and it's really a bit of a disaster. Obviously, you can do things like designing receiver for strong signal handling. For example, the one that Geo sell, the R2ZX, is particularly designed for that purpose. You can build a little notch filter for getting rid of some of the interference, or at least reducing the amount of interference. And you can even ask people like Noah to say, well, you've got a couple of frequencies, could you use the one furthest away from the pagers, please? And I'm delighted to say that actually Geo has sufficiently good relationship with people like EUMETSAT and NASA, and NOAA rather, that they have actually moved the frequency of one of the satellites to the low end, to an unused frequency. This is the sort of picture that I typically get today, even with all the sort of filters and trying to reduce the interference. And that's really not particularly attractive. I think, Francis, today you didn't have any trouble with pager interference here. No. So to me, being sort of VHF enthusiast living on the top of a hill right near a mast, well, it's a stupid place to do this. So you can build yourself a little notch filter and move on to the green now, since it's good. A simple resonance circuit coupled in to the signal path. It's not acting as a peak, it's actually acting as a notch. It sucks out energy, and that's a sort of physical implementation of it. So the difficulty being you can't use a quarter wave stub or something like that because the interference is about 600 kilohertz away. So you're either into the cavity filters that you use for a repeater or something similar like that. That doesn't tend to drift too much with temperature being in the shaft, which is quite nice. But you don't need to do any of that. Because if you are of interest, then that's the way to go, is the direct reception. If you're actually more interested in the images and making an animation from them, then UMedCast, the sort of system we've got outside, is an easier way to do things these days. Basically, it consists of a standard satellite TV dish, low noise block. I always used to wonder what a low noise block was. Shall we say RF amplifier, mixer, local oscillator. Bring the signal down to about 1.1 gigahertz IF, so you can bring it down on standard cable. And a low-cost box that will just go from DVB, the digital video broadcasting signals, into your PC. But have to, and a couple of bits of software to convert the DVB stream into files, and then to convert those files into images. These are the magic numbers. Of course, you don't have to know any of that. You just click on install and it does all that for you, but you can see what the correction is and so on. It's on Hotbird 6. They're all standard stuff. And what does standard mean? It means low cost. It means you can get it from the Geo shop. It's cheap. It's no longer the dedicated £5,000 receiver or £500 receiver that you'd have to buy from the manufacturers before. It's cheap. It's easy. The antenna, standard antenna. And yes, because I'm in Edinburgh, those of you very near the front can see a little snow shield. And that's the major problem with this stuff. It's actually rain, of course, you some attenuation, and snow that can get onto the antenna, rather than actually blocking the signal. 2 or 3 times a year, that's all. To receive now, you used to have to open up your PC. Some people would be dubious about it. Open up the PC, oh dear, it's a little sticker on the back that says do not open. But you don't need to do that anymore now. You can get a little box. This one's a DEXAtech box. And really simple, you feed 12 volts in, you feed the 1.1 gigahertz in, and you get USB coming out. And rather like my mouse, it has a bright blue LED on, so it must be working. It really makes it very easy. That just goes into your receiver, into your PC. You buy some software from UMedSat and a dongle that goes on the back of the PC. That'll cost you about €100. And there's also a similar system in the States, which I'll maybe come on to. There's a similar system called a GeoNet cast that's got a NOAA cast, I think it's called. Also has cast at the end of it. It's called cast because it's called broadcast, which means if you miss it, it's gone. You can't get it back. So, similar sort of software, provides remote monitoring facilities and so on. And you can see this being demonstrated outside. So if you've got any questions on that, I suggest asking at the end, and the guys outside with their kit. My own software takes the files that we've got. The stuff you get down from UMedCast is effectively a set of segment files. You don't transmit the whole image at once, because that would be too many megabytes to send down reasonably. So you actually split the image into segments, 8 strips or 24 strips. And then if you miss one segment, because I say it's a broadcast system, if you miss one segment, it doesn't matter, you've just got the one segment missing, not the whole image. And so my software will reassemble that and turn it into JPEG images or PNG images. And if you want to animate that, you can put a set of those images together. And also software that I do called GeoSat Signal will enable you to not only put the images together, but also reproject them. So if you've got a mean sea level pressure chart from Bracknell that's in a particular projection, GeoSat Signal will match the satellite image to that and combine the whole thing together for you. Again, leaflets outside. I can't take orders today, sorry. So the sort of thing we're getting from Meteosat 9 is rather like we've seen from the APT images. There are in fact 12 channels of data. you'll be absolutely delighted here. I'm not going to go through all 12. There's a visible channel, which you saw. There's a thermal channel again. Now, this is perhaps slightly more recent data. You can see black being hot, so Africa looks a bit cooler, North Africa looks a bit cooler, and so on. And you've got, so should we start with hotter again, excuse me. Africa, both north and south looking hot, cold clouds. Just as I showed for the APT images, you can use software to produce this. And in fact, you can use the visible channel, actually 2 visible channels on the satellite, one of which particularly is 0.8 micrometers, and where chlorophyll vegetation, the chlorophyll causes it to reflect well, and the 0.6 micrometers where it doesn't reflect quite so well. So you can actually get an area of sort of vegetation type of color just from that false color processing. Particularly if you look at some of the images that Francis has got outside, I think you'll find one shows the Nile very well, and just that cultivated area with a few kilometers on either side of the Nile stands out very prominently. This is just magnifying in, zooming in to see that's roughly the sort of resolution you get. That's about 1-to-1 resolution from those full images. There is actually an extra channel on Meteosat that provides a higher resolution, about 1 kilometer at the equator, perhaps about 2 kilometers where we are, and this is the sort of quality. So you need to come close to be able to see the sort of quality we got here. But
I was interested earlier on that one of our colleagues was
identifying somewhere near Hanover to see whether the storms had come, and he could quite clearly see a lake that he recognized. So that's the sort of resolution. Not only that, I'm trying to see how we're doing time-wise. Not only the Meteosat 8 and Meteosat 9. Meteosat 8, they've got 2 satellites. EUMETSAT have got 2 satellites at 0 degrees. And whilst Meteosat 9 is the primary one, giving images every 15 minutes, there's also, what do we do with Meteosat 8? Well, we might as well keep it running. And that's actually providing a service now of data every 5 minutes. So you can make very smooth animations, and of course if you're doing a sort of nowcasting type of application where you're wanting to see precisely when it's going to rain, will it be before the pit stop or after the pit stop? You've got Meteosat 8 that can provide you with that sort of 5-minute resolution data. But what EUMETSAT have done in buying this link through Hotbird, it gives them actually lots of bandwidth. So they're not able to put only the local data on. Data from American satellites once every hour goes east and goes west, covering roughly the east and west coast of the Americas. The old Meteosat 7 satellite that maybe some of you received WeFAX signals from, that's been gradually shifted across, is now sitting over the Indian Ocean, and you get pictures from that. No extra charge. It's free. Sign up that, oh, you're an amateur and you're not going to rebroadcast it in competition with the BBC or something. You have Chinese data, and there's Australasian data. So we've got to just demonstrate what we mean. We've got the west coast of the USA here, just about make out Hawaii somewhere there, and just coverage into the polar regions. East coast of the USA, fun to make an animation watching these storms track across where they start off in Africa, then gradually move across there. Good coverage of South America, of course. And in fact, there's also a sort of an Atlantic bird link that is pointing to South America, providing this type of service, broadcast service. The European and African coverage that you've seen, Indian Ocean coverage, and Australasian coverage. So, this is all coming in on the same data stream. No extra charge. The software receives it all, animates it. Your problem is to decide what to look at. You've got all these pictures changing all the time. What are you going to do with them? Polar orbiter, there's even more on EUMETCAST, not just geostationary. Oh no. We've got polar orbiter data there as well. Essentially 3 ways of getting polar orbiter data. One is from NOAA 17 and NOAA 18. What EUMETSAT have done is to set up receiving stations. So keep me on the time, Chairman. No, good. The Chairman there. Right. I thought you disappeared. I thought I'd got the whole afternoon. So very briefly, they've set up receiving stations, one coming online in Athens, one in Gran Canaria, one in France, one in Svalbard, and one in Gander. And as NOAA 17 gradually passes from station to station, all the data being received is fed into one big box in EUMETSAT, and they take the best bits of each of the paths, each of the different stations, and feed it out over EUMETcast. So you'll have again seen the sort of stuff that John's been displaying. Oh, that's exciting. Oh, this is the hint, the big hint. Sorry, minor power glitch there for folks worldwide, sorry about that. Free, again, 1 kilometre resolution, near real-time data. The fact that the other data that I'm going to talk about, very briefly, worldwide coverage from NOAA 18, goes round, dumps its data out once per orbit at one of the American stations, possibly in Alaska, and that data is sent down. Now, the recording capacity on NOAA 18 is limited, so they can only do relatively low resolution data, but it's the same sort of quality as you'd get from APT, which means it's about 4 kilometers resolution. Quite fine for watching some of the hurricanes and things like that. But we don't want to give you that. It's also METOP-A as well, which is the new European polar orbiting satellite, 1 kilometer resolution, and that is also dumped at a station over Svalbard, and that data is sent out over EUMETcast as well. You'll start asking me how much. It keeps going on about adding data. Yes, there is more and more data. If you take the whole stream, it's something like 40 gigabytes per day. So you buy a new hard disk every 10 days. So you do need to be able to manage the data. This is the NOAA 18 worldview data. You can't see it very well, but it's scanning in strips. I've got an animation, but there won't be time to show it, unfortunately. So my apologies to Jean-Pierre. I don't have time to show that. You can just make out a strip there. And again, this is a piece of software that I wrote that takes the individual little strips of data and puts it onto one world view, and that essentially updates once per day. Sort of resolution you can get there, again, is good enough to show things like Hurricane Bertha. So that's the low resolution data. You go into the high resolution data, again taking Hurricane Bertha, by recording a few days worth of data. You don't know that that is going to amount to anything, but in fact one of our people, Bernard Burton, had this image and was able to go back, having seen how Bertha developed, was then able to go back and trace it from its origins over Africa. He's a meteorologist, so he's particularly interested to look at this cloud top structure that's there. And that's the sort of final picture that I did as a more pretty picture type image, you know, a nice one to have on the wall. Now, somewhere up there, there's about half a dozen pixels of Bermuda. When you think of Bermuda being, you know, it's so tiny compared to this. It's frightening to think what happens when that goes over. Although these things are very beautiful to see, it must be not a nice experience at all. So your heart does go out to them. And there's more, but obviously we don't have time for that. There's worldwide wind data from scatterometer data looking at sea winds. There's information on land and sea surface temperatures. Also from the METOP satellite, that is actually carrying a GPS occultation instrument called GRASS. And the data from that is also available. I think you may have to sign up specially for that, but from the point of view of what you're interested in, maybe that's something that some people could actually look at. Oh, right, so very briefly then, what's a nicey time, wasn't it? Thank you, Graham. We've looked at polar and geostationary satellites. We've looked at direct reception that you can get from the polar orbiting satellites. We've looked at the indirect reception we've had from geostationary satellites via EUMETcast. EUMETcast being very quick and easy and providing you with a whole mass of data and absolutely stunning images. Your challenge is how to use all that data and enjoy it. I'm going to thank Amsat, I'm going to thank BATC providing us with a worldwide audience, to Bernard Burton for the images, Noah, I guess, have the copyright. UMetSat and Noah have the copyright. But guys, thanks for the last presentation. Thanks for not falling asleep. I do suggest, by the way, since we are towards the end of time, or was that Messian, that maybe questions might be better at the stand outside, and we can actually show you some of the data there. Unless there's any burning questions.
Any burning issues? No?
Good.
Okay. Thank you very much.